Today, we are diving deep into one of the biggest questions we can possibly ask. Are we alone? And what's our place in this absolutely massive, dynamic, and, well, sometimes pretty violent universe? Let's get into it. We tend to think of Earth as this cozy, safe little harbor in the middle of a vast cosmic ocean. But what if it isn't? What if the universe is way wilder and stranger than we even imagine? That question right there, that's our real starting point. And to kick things off, just try to wrap your head around this. The universe isn't just quiet, empty space. Oh no. It's a place where entire suns, we're talking octillions of tons of mass, can be shot through the void at speeds that just boggle the mind. And this isn't sci-fi, this is really happening in our own galaxy. Which brings us right to our first section. So forget about a calm, peaceful existence. We're about to see just how chaotic the universe can really be, starting with these incredible cosmic projectiles. So what are these things? Well, they're called hypervelocity stars. These are suns that have been literally kicked out of their home galaxy at speeds that are almost impossible to even comprehend. And the usual culprit behind this cosmic eviction notice? It's typically the most powerful object we know of. So how on earth does this happen? Think of it like a cosmic slingshot, or maybe an Olympic hammer throw. You have a pair of stars that are orbiting each other, a binary system, and they wander just a little too close to the supermassive black hole at the center of our galaxy. The black hole's insane gravity grabs one star, pulling it into a super tight orbit. But all the energy from that capture has to go somewhere, and it gets transferred to the other star, launching it out into deep space. Can you just imagine being on a planet that hitched a ride with one of these stars? I mean, the view would be both magnificent and just terrifyingly lonely. You'd literally watch our entire galaxy, the Milky Way, just shrink into a distant, beautiful swirl of light as you journey into the great empty unknown. But the universe isn't all about destruction. It's also an incredible factory for creation. So for our next section, we're going to shift gears from cosmic violence to the cosmic ingredients, the fundamental recipe you need to build life itself. For life as we know it, you need a few key chemical elements. And the big one, the absolute MVP, is carbon. We call it the architect. Its incredible versatility lets it form these long, complex molecules that are the backbone of, well, every living thing on Earth. So here's the crucial point. Where do these ingredients even come from? They aren't just lying around. They're actually forged in the nuclear furnaces inside stars. And then they're scattered all across the cosmos when those stars die in these spectacular explosions called supernova. I mean, the death of stars is literally the birth of life. Okay, so how did those ingredients get right here, to Earth? Well, back in the chaotic early days of our solar system, comets and asteroids basically acted as a cosmic delivery service. They slammed into the young Earth over and over again, seeding it with water and these crucial organic compounds. And what that means is the recipe for life isn't unique to us. It's likely available all over our solar system. All right, so if the building blocks for life are everywhere, it just makes sense to start our search close to home, right? So let's begin this quest right here in our own backyard, taking a look for clues on our planetary neighbor, Mars. And guess what? We found something absolutely incredible. Back in 2018, the Curiosity rover drilled into what used to be a lake on Mars billions of years ago, and it found the very things we've been talking about, organic molecules. Now hold on, this isn't proof of Martians, but it is a seriously tantalizing sign that Mars might have once had the right stuff for life. This discovery, it leads to a truly mind-bending question. What if life didn't even start here? What if we are all, in a way, Martians? It's a theory that would just fundamentally change everything we think we know about our own origins. This wild idea actually has a name. It's called panspermia. The theory goes that a huge asteroid impact could blast rocks with tiny microbial stowaways from one planet to another. And we actually know it's possible. There was an experiment on the International Space Station that proved some microbes can absolutely survive the harsh vacuum and radiation of space. So, simple life, hopping from planet to planet, that's one thing. But what about intelligent life, the kind that builds cities, harnesses stars, and sends messages out into the cosmos? To find them, we have to look way, way beyond our own solar system. Now, to even think about advanced life, we use this framework called the Kardashev scale.
Basically, it classifies civilizations by how much energy they can control. A Type 1 civilization controls its entire planet. A Type 2, its star. And a Type 3, well, its entire galaxy. And you might be wondering, where are we? As you can see, we haven't even hit Type 1 yet. We're sort of lagging behind at about a 0.7. A civilization that advanced would need a ridiculous amount of energy, right? That could lead them to build something called a Dyson sphere, a megastructure that completely surrounds their star to capture every last drop of its power. Now, a structure like that would block the star's light, but it would have to radiate waste heat, so it would glow brightly in infrared light. So we looked. We scanned 100,000 galaxies looking for that exact signature. And the result? An eerie silence. Not a single credible sign.
So maybe we're just looking in the wrong places. The most common type of star out there are red dwarfs, and their planets are often tidally locked, meaning one side always faces the star. This creates these really extreme worlds. One side is a scorched desert, the other a frozen wasteland. But in between, there's a twilight zone, this ribbon of permanent dusk where liquid water and maybe life could actually exist.
And all of this brings us to the final and I think most profound part of our journey today. We've seen that the ingredients for life are everywhere. There are trillions of planets, and yet our search has come up completely empty. So we have to confront this great cosmic silence. And this right here, this is the heart of the mystery. It's famously known as the Fermi paradox. The numbers, the sheer probability, suggest the galaxy should be teeming with civilizations. So, why do we see absolutely no evidence of them? Where is everybody? One potential answer is a pretty chilling concept called the Great Filter. It's this idea that there's some kind of barrier, some incredibly difficult step in the evolution of life that is almost impossible for any species to overcome. And this filter, it could be the reason the cosmos is so quiet. So what could this filter be? Honestly, the possibilities are sobering. It could be a cosmic catastrophe, like a gamma-ray burst that just sterilizes entire galaxies. Or maybe the jump from a single cell to complex life is just unbelievably rare. Or, and this is maybe the most terrifying thought, perhaps the filter is something intelligent species do to themselves. The moment they discover technologies powerful enough to change their world, they also create the tools for their own destruction. And this is why this search is so important. Finding the ruins of an extinct alien civilization, that wouldn't just be a discovery, it would be a warning. It would be like staring into a mirror of our own possible future, a grim lesson that we would have to learn from, and fast. And so that leaves us with this final massive question. Is our existence here on Earth a 1 in a trillion miracle, this precious, unique spark of consciousness in an otherwise silent universe? Or are we just another civilization heading toward our own great filter? A story that has already played out countless times before, serving as a cosmic warning to anyone who might someday find our ruins. The answer is still out there.